we do this thing called training, where we have to feed the loss back into the model and make certain adjustments to the model to improve this predicted output. Let's talk a little bit about the training. What exactly goes on during that step? Let's go back and take a look at our L2 loss function. This is what our L2 loss function looks like. It's a quadratic formula, right? Well, up here, the error is really, 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 really large. And our goal is to get somewhere down here where the loss is decreased, right? Because that means that our predicted value is closer to our true value. So that means that we want to go this way, okay? And thanks to a lot of properties of math, something that we can do is called gradient descent in order to follow this slope down this way. This quadratic it has different slopes with respect to some value. Okay, so the loss with respect to some weight W0 versus W1 versus Wn, they might all be different, right? So some way that I kind of think about it is, to what extent is this value contributing to our loss? And we can actually figure that out through some calculus, which we're not going to touch up on in this specific course, but if you want to learn more about neural nets, you should probably also learn some calculus and figure out what exactly backpropagation is doing in order to actually calculate, how much do we have to backstep by. So the thing is here, you might notice that this follows this curve at all of these different points. And the closer we get to the bottom, the smaller this step becomes. Now stick with me here. So my new value, this is what we call a weight update. I'm gonna take W0 and I'm gonna set some new value for W0. And what I'm gonna set for that is the old value of W0 plus some factor, which I'll just call alpha for now, times whatever this arrow is. So that's basically saying, okay, take our old W0, our old weight, and just decrease it this way. So I guess increase it in this direction, right? Like take a step in this direction, but this alpha here is telling us, okay, don't take a huge step, right? Just in case we're wrong, take a small step. Take a small step in that direction, see if we get any closer. And for those of you who, do want to look more into the mathematics of things, the reason why I use a plus here is because this here is the negative gradient, right? If this were if you were to use the actual gradient, this should be a minus. Now this alpha is something that we call the learning rate, okay? And that adjusts how quickly we're taking steps